Hello everyone, I'm Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. In today's lecture, we will talk about Bargellini reaction. In this reaction, phenol react with acetone or ketone in the presence of base and also in the presence of chloroform to produce substituted phenoxide carboxylic acid. This reaction was later modified to synthesize different types of hydroxide compounds like morpholinones and piperazinones. So what is the mechanism of this reaction to synthesize substituted phenoxide carboxylic acid? In the first step, when base abstract proton from the chloroform, so carbanion is produced, and then this carbanion react with acetone or different types of ketone, and the bond will be break towards oxygen atom. So this type of alkoxide is produced in this step. And in the next step, this alkoxide ion will attack on the carbon atom to which three different halogen atom is attached, and as a result oxirane is produced in this step. It is oxirane, or it may be also you can call it epoxide. So in the next step, this phenoxide will attack on the oxirane carbon to which two different methyl groups attach. So how this phenoxide ion is produced? As we know that phenol is present in the reaction mixture and it is carried out in the presence of base. So when base ionize, it is ionized into Na plus and OH minus. Then this OH abstract phenolic proton, as we already know that phenol is slightly acidic in nature. Due to this reason, when phenol react with the NaOH or KOH, the phenolic proton is removed and it is converted into phenoxide ion. Then this phenoxide ion will attack on the carbon of this oxirane ring, and the bond will be break towards oxygen atom. How? Like this. It is carbon to which two different methyl group is attached and it is phenoxide ion. So the bond break toward oxygen atom, so alkoxide ion is produced, and here two halogen atom is present. So in the next step what will happen? And in the next step this oxygen will form bond with this carbon atom, and as a result one of the halogen atom will lose this functionality, and it will be converted into acid halide. Like this. Acid halide is produced in the reaction. As we already know that the reaction is carried out in the presence of base. So OH of base will attack on the acid halide and the bond will be glued towards halogen, and this halogen will leave the group and it will be converted into carboxylic acid. So this is the final structure for this reaction. As you can see here that substituted phenoxide carboxylic acid is produced in this type of reaction. As we'll discuss in the first slide that the reaction is modified into the synthesis of such type of heterocyclic compound like morpholinone and piperazinones by reacting it with ketone and chloroform in the presence of base. In this reaction, two different types of this substrate is used, in which X is maybe oxygen or it may be nitrogen. And when oxygen is used, it produces morpholinone, and when NH is present, then it is used for the synthesis of piperazine. So what will be the reaction mechanism for this reaction? As we already discussed that base will abstract chloroform proton, and it will take the deprotonation, and as a result this carbanion will be produced. In the next step, this carbanion will attack on the carbonylic functionality of ketone or acetone, and as a result the bond will be break towards oxygen atom, and alkoxide ion will be produced. And in the next step this alkoxide ion will attack on the carbon to which two different halogen atom is attached, to which three different halogen atom is attached. So as a result when this alkoxide ion attack on the carbon atom, one of the halogen atom will be removed, and this type of oxirane is the product of this step oxirane or epoxide. So in the next step, this primary amine will attack on this oxirane carbon atom to which two different methyl group is attached, and the bond will be break towards oxygen atom as we already discussed, and then alkoxide ion is produced. And in the next step what will happen, it will form carbonyl functionality, and one of the halogen atom will remove from this group, and as a result acid halide will be produced. This type of acid halide will be produced. And in the next step, this XH will attack on the carbonylic functionality of acid halide, and it will cyclize to produce this type of product. It may be nitrogen or it may be oxygen. So if we discuss the application of this reaction, here it is the application of such type of reaction. So when one of the group is NH2 and the other one is OH, as we talk about that X may be oxygen or nitrogen. So in this case X is oxygen, so it is alcohol. First oxirane will be produced, and then upon oxirane this NH2 will attack and the bond will be glued towards oxygen atom, and it will produce acid halide, and upon acid halide oxygen of this product will attack and it is cyclized to produce this product. And in the next step and in the next example, first oxirane will be produced, and upon oxirane this NH2 will attack, and it will produce or it will be converted into acid halide, and upon acid halide this NH will attack and it will be cyclized to produce this product. Thank you so much for watching. If you like the video, please like and subscribe my YouTube channel, and if you have any type of question you may ask in the comment section. Thank you so much. The Allah Paman.